Yoon, and today I'm going to cover the chapter 11, the process design and the analysis. The learning objective for this chapter is to identify the typical business process and how can it be analyzed. The second thing is to compare the different type of processes. The third one is to explain how jobs are designed. The last one is to analyze manufacturing, service, and logistic process to ensure the comparative of a firm. First of all, about the process analysis, what's the process? The process is any part of the organization that take the input and transform them into the output. So, and to the cycle time. The cycle time is the average successive time between the completion of the successive unit. And the third thing is the utilization, the ratio of the time that a resource is actually activated related to the time is available to use. So we come to an example to analyzing the Las Vegas slot machine. First of all, the analyzing the mechanical slot machine. This is how it functions. You put the coin into the machine, you pull the handle, and you get a result. Then the second thing is to analyzing the new electronic slot machine to see what's the difference between the mechanical and the new one. And into the third step to compare between the two slot machine to see which one is working better. The slot machine is just one of the many casino processes. Many of them function differently, but the outcomes usually be the same. And the process flow charting, this one is the use of the diagram to represent the major element of the process. What does it mean? Basically, it's the process from the beginning to the end, when the customer put the coin into the machine, and the outcome would be the decision of the customer to continue to play or to quit. The basic element can include the task and operation, the flow of material and customer decision, and the storage area or queue. It's an ideal methodology by which to begin analyzing the process. The first way to characterize the processes is to determine whether it's the single task process or the multitask process. And between the multitask process, there's the buffering between each step. What does it mean? It's the storage area between the state where the output of a state is played prior to being used in the downstream state. Then the next thing we need to consider is the blocking. What's the blocking? The blocking is the process. The step occurs when the activity in the state must stop because there's no place to deposit the item. Then we come into a new term. This is stopping. The stopping is not when you're hungry or something. It is the step when occurs when the activity in the state must stop because there's no work to do. And the last thing we need to keep in mind, that's the bottleneck. Bottleneck that is the resource that limit the capacity or the maximum output of the process. There's always other types of the processes. The first one is serial flow process. It's a single path for all stage of production. The next one is the parallel process. The parallel process is some production. That's an alternative part where two or more machines is used to increase capacity. And the last thing will be logistic processes. This one is the movement of things such as material, people, and finished goods. So there's another useful way to characterize the process. Is whether the process can make to stock or make to order. What is make to order? Make to order is this one is only active in response to an actual order. Both work in process and finished good inventory kept to a minimum. And what is make to order? Make to order to the process activate only to meet the expected or forecast demand. Customer order as from the target stocking level. And also there's a third one. The third one is a combination of those two. The is the combined feature of both make to order and make to stock. So how to measuring the process performance? First one we come into the operation time. To calculate the operation time is the combination. We add the setup time and the run time to become operation time. The flow time actually is the average time for the unit to move through the system. The velocity is the value added time divided by flow time, and the cycle time is the average time between the completion of the unit. For example, for the first unit and the second unit, the time gap between those two is the cycle time. The throughput rate is the 1 divided by cycle time. The efficiency is calculated by actual output divided by standard output. But productivity is equal to output divided by input. And the last thing is utilization is the time activated divided by time available. So going to the production process mapping and little loss. The total average value of inventory. The sum of value of raw material, work in process, and finished good inventory. The inventory turn is the cost of goods sold divided by the average inventory value. The day of supply inverse of inventory turn scale to days. And the last thing is little loss. Little loss is this is a long-term relationship among inventory throughput and flow time. The inventory, if how to calculate inventory, is equal to a throughput rate multiplied by the flow time. For example, it's the car battery. The average cost is $45, and it takes 12 hours to make a car. So example, 200 cars per 8-hour shift. So on average 8,000 battery in raw material inventory. So the calculation would be 8,000 plus 300 to become 8,300 batteries, and the value and the flow time would be 8,300 multiplied by 45. So the result would be $375,000, and the flow time would be $8,000 divided by 200 would be 40 days. Behavioral consideration in job design. This specialization of labor and to make high-speed and low-cost production possible, and to greatly enhance the standard of living to avert the effect on worker. Job enrichment, to make a job more interesting to a worker. And the two terms for enrichment is horizontal enrichment and vertical enrichment. Horizontal enrichment is the worker perform in a greater numbers of variety of tasks, and vertical is the worker who involved in planning, organizing, and inspecting work. Work measurement standard. What's a work measurement? Work measurement is a process of analyzing job for the purpose of setting time standards. So the purpose why we use the work measurement is to schedule work, allocate capacity, and to motivate and measure work performance, and to bid for a new contract, and to evaluate the performance for assisting one. For some questions, just as can we do it, how we doing it, and presume the assistant of the standard. The last one is to provide a benchmark for improvement. In addition to internal evaluation, benchmark team regularly compare work standard in the company with those similar work in the other organization. There's some work measurement techniques such as to the direct method, which is time study and work sampling, and the indirect methods to predetermine motion time data system and elemental data. For bread making to running at 100 roll per hour, so capacity would be 100 roll per hour, and packaging is idle for quarter hour. Both bread and making and packaging operator the same amount of time. So the bread making run 2 shifts would be the 200 multiplied by 8 multiplied by 2 will be 3200, and the packaging run 3 shifts would be 133.3 multiplied by 8 multiplied by 3 will be the 3200. The capacity are roughly equal. The next example is still a restaurant. Consider a restaurant in the casino, because there is important that customer can be served quickly, so the manager has set up a buffet arrangement where customers serve themselves. The buffet purpose is to keep the item fresh, so to further speed up the service. So to fix the amount charge is for the meal, and customer take average of 30 minutes to get their food and eat, and they typically eat in group of 2 or 3 to a table. The restaurant have 40 tables. So the maximum capacity of this restaurant is they they could handle up to 80 customer party per hour. The challenge in the restaurant problem is everyone want to eat at the same time, so the management have to collect data and expect the following profile for customer party arriving during lunch. Would run from 11 a.m. to 1:30 p.m. and customers are only seated until 1 p.m. The restaurant operates for 2 hours for lunch, and the capacity is 80 customer party per hour. A simple way to analyze the situation is to calculate how we expect the system look in terms of a number of customers being served and the amount of waiting in line at the end of each 15-minute interval. The key to understand the analysis is to look at the cumulative numbers. The difference between the cumulative arrival and cumulative departure gives the amount of custom per party in the restaurant. Because there are only 40 tables, when the cumulative difference through the time row greater than 40, so waiting line form. The circle time for the entire restaurant is 45 seconds per customer party at this time. The last party will need to wait all of the earlier party to get a table, so expect waiting time is the number of party in line multiplied by the circle time. Initial analysis for a tourist bus, a 2 hour for road during peak traffic. The road has 60 stops. Experts have setting up a capacity of 50. Busy much of the day. So with one bus, maximum wait is 2 hours. If the bus is halfway through the circle and wait is at 1 hour, average wait is one half of circle time. If 2 buses is used, the circle time is 1 hour and average is 30 minutes. For a 2-minute wait, we need 4 minutes circle time and we need at least 30 buses. Its bus have capacity of 80 passengers, is 50 seats and 30 standing. 30 buses can accommodate 1,500 seats and 2,400 total, including sitting and standing. For conclusion, with 30 buses, many will have to stand, and during morning afternoon rush, not all customers can be accommodated because there's not a best way in one bus to be, even if you want to stand in the bus. So with 40 buses at the same time, 24,000 seats are available, and 25,875 seats are needed. Process flow time prediction is performed by activity in parallel and the change in sequence of activity and reduce the interruption. And that covers the chapter 11, the process design and analysis. Thank you for listening.